Hello, so today we are doing this problem called maximum product subarray, and the problem says we get an array limbs and we want to find the contiguous subarray within an array that contains at least one number which has the largest product. So we could have something like 2, 3 minus 2, 4 here, and the largest product can be obtained by multiplying 2 and 3 to get 6. So contiguous here, it means it's not a subsequence. We can't have gaps. Like we can't take multiply 2 and 3 and then multiply by 4. We can't skip this number in between. But this number makes it smaller, and so that's why the largest one is this one. For this one, minus 2, 0, minus 1, the largest one is 0 because if we include minus 2, it's going to be still 0. So, and if we include minus 1, it's still 0. So the product of all of them is 0. But we can't just do, if we do just minus 2, that will be smaller than 0. And we can't skip this 0. We can't take just minus 2 and minus 1 because that's not contiguous anymore. So that's the problem. Now, how can we solve it? So for this problem, the thing is that makes the problem a little bit like different. Like if it was just positive numbers, it would be really easy to do, right? Just the product is just all of them, right? And so let's just go from the simplest case and then gradually increase. So simplest case is, this is a useful thing to try to do. So simplest case is only positive numbers, right? Now second, so simplest case, let's call it 1, and then after that we can handle the slightly more complex, which is positive numbers and 0, an array that can contain both positive number and 0, because whenever we encounter 0, if we take it, it makes the product become 0, and so we need to take basically the product is the max between what's left of 0 and what's right of 0, because 0 just makes the product smaller and equal to 0, right? What makes things even more complicated, which is what the problem is asking, is having negative numbers, positive numbers, and negative numbers, right? Because when you have negative numbers, like you could have, let's say, 18, a big number, 2, and then you encounter minus 1 and 2. Minus 1 just makes this entire big number here becomes like, let's say, 18 multiplied by 2. What's that? 36. So it makes 36 become minus 36, which is really smaller than even 2, right? And so the maximum product will be anything not including that negative value, right? But the negative values make things even more complicated, right? Because we might have, let's say, after this 2, we might have minus 4, right? Now, the maximum product is the entire thing, because if you multiply minus 1 with minus 4, you get 4, right? And so this entire thing is 36 multiplied by, the biggest product is 36 multiplied by 2, multiplied by minus 1, multiplied by 2, multiplied by minus 4, because now this minus 4 made the number that was negative become positive, and so it became really bigger than anything else we could achieve. And so negative numbers, if there is only one, then whatever left of it and right of it is bigger. If we have multiple negative numbers, an even number of negative numbers, which means then minus would make a positive number, then in that point we would have to consider the entire sequence, the entire contiguous range as the max product. And so you get the idea how negative numbers complicate things. And so let's just try to solve the simplest case first and then go from there. So for the simplest case, we can just go through the array and just have a product, right? Initialize it to 1, and then just go to the array and multiply all of them. Because that's the biggest thing we can achieve, and return that, right? So that's pretty straightforward. Now for the 0 case, what should we change in this solution? So for the 0 case is that if the number is, so all is fine here, but if num is 0, that means the product became 0, and so we need to reset it to 1, and basically just do something like this, where if we have 2, 1, 0, 4, then whenever you find, so the product here becomes, so the product, let's call it P, becomes 2 here at this point, and then when we move to this, it becomes, well, let's take this as 3. It becomes, P here becomes 6, but the problem is here P becomes 0, and if we continue taking it as 0, we will only find smaller products, right? And so to do that, we are just going to make it 1, which is basically just resetting it. So this is reset, so that when we get to 4, we can consider only the sequence, the contiguous subarray of 4, right? So that's what we'll be doing here. But because of this, we will need to keep track now of a best value, because we don't know if the best value is left of 0 or if it's to the right of 0, right? So we need to keep track of best value. Let's initialize it to maybe the smallest number possible, so that whatever we put in with the max, it's going to be the max, right? And so what's going to happen is that here we will keep track of the best product that we found so far, right? And we return the best instead. And so you can see the only difference between this and this one is that when we encounter 0, we reset the product so that we can restart the range from whatever is after 0, because 0 just makes the product smaller, right? Okay, now how can we handle this more complicated case that the problem asks of us? So here, what does change? The problem with negative numbers is that, let's say you had 4, right? And you encounter a positive number 2. At that point, okay, this is bigger certainly because this is 8. But if you had 4 and you encounter -2, this number is smaller, right? And if you had, let's say, 3 and you encounter -2, this number is -6. But here, if you had 3 and encounter 2, the number becomes 6, right? The product. So what's the difference here? It's when it's a negative number, the bigger number is smaller. When it's so you can see here, this one was bigger, but here this is smaller than -6. But here this is bigger than 6. So you get the idea. It's reversed, right? Right? When you encounter a negative number, when encountering a negative number, the bigger product becomes the smaller one. Right? But this is only if, when encountering a negative number, the bigger positive product becomes a smaller one. Because if we had a product, let's say, of -8, and then we encounter -3, and then we had a product of -6, and we encounter -3 again, so this one is, or let's take 2, that would be easier to calculate. Then this here would be 16, and this here would be 12, right? So you can see when we encounter a negative and the product was negative, 16 is bigger than 12. And so where the number was smaller, the negative number was smaller, now the product became bigger. So you can see the difference. It gets reversed. Every time we encounter a negative number. What do I mean by it here? What gets reversed is max product becomes the min product, or the bigger product becomes the smaller product, and smaller product becomes the bigger product, right? And since we are looking for the biggest product overall, we need to just keep track of both, so that every time we check both, because we don't know if we will encounter a negative number, an even number of negative numbers, or an odd number of negative numbers. We don't know. And so let's just keep track of min product and max product. And so what would change compared to this solution here? So what will change, instead of checking for number equal to 0, now we want to check for number less than 0. And we need to keep track of 2 things, min product and max product, right? So let's initialize both of them to 1. And now, if number is less than 0, what we said is bigger product becomes the smaller, and the smaller product becomes the bigger. And so that means we just need to swap min product with max product. And then we need to keep track of the max product at every point and keep track of the min product at each point. And of course, since this always keeps the track of the maximum product, then the best is the best so far compared to the max product. So what's the max product? It's just the max of the previous max product that we have multiplied by the new number that we just found, or the max product, previous max product. So when does this becomes bigger? If number is negative, then this is bigger, right? But if number is negative and the product was negative, right? And so we would have swapped with min product and multiplied by the negative number, and that becomes the overall big number, and we put that at max product. And so for this one, it's max product, it's min product, the min of min product multiplied by nim, and nim here too, yeah. And so that's what changes between the solution that we had before and the new one. It's that we need to keep track of both, because we don't know when it flips, when one of them becomes the bigger and the other one becomes the smaller. And the flip happens only when we encounter a negative number, because in both cases, if we had a product that is negative and we multiplied by a negative number, then the order of which is bigger flips. And the same thing when we had a positive number and we encounter a negative number, the order also flips, right? And so that's what we are doing here. But what we are doing here is just the same, like, especially for 0, if a number is equal to 0 and this one became 0, then we should just restart with the new, with whatever new number we found. So if the product was 0, the max product was 0 because the previous number was 0, then the new number, let's say in this case 4, is what's going to take over here. And so that's what, and the same thing for min product. And so yeah, so that's the solution for our last case. So let's just replace it here. And that's pretty much it. So let's run. Okay, let's try some other use cases, like an empty list 1, maybe 2, -5, -8, and then let's try this one, and let's try, do we have another one? Okay, this seems good enough. Okay, so here I'm returning -infinity. I should probably just initialize this with 0 then. Okay, so now looks like it's the same. There is no difference. We have a problem for this case, -2. It says 0, but it should say, okay, so I guess what's missing here is that this basically should be so -2 case. So I guess we should just take this, if it contains, or otherwise just do okay, what about just 1? What happens? Yeah, we have value for the 1 -2. Okay, so that doesn't work. So I think what we should do is just handle the case. So if length of nim is bigger than 0, then we could just say give at that point the first number as the best. Else, what should we do as the default value? Did they say? So they said the array contains at least one number. So I guess we shouldn't care about the empty case. So let's just do that then. Yeah, my test case here is not needed. Okay, submit. Okay, so that passes. Okay, so another way to think about solving this problem is so it's very similar to what I did in the last solution, except what I can do is not explicitly swap and check, just do that regardless, right? And so that means basically that I just say, okay, so here I started with 0 and I don't need to do the check, just every time make max prod be the max of all of them. So if the swap happens, don't do the swap and just by default just say, okay, min product multiplied by nim. And so this will, if the number was negative, it will act as doing the swap, right? But to not override this before using it here, because we will also need to do the same for min product, because this will do the same thing as the swap. If the number turns out to be bigger because we multiplied by negative, then we do the same thing. So all of them have the same, we just take the max of all of them. And then I just need to do it here so that I don't override it before using it. And that's pretty much it. And so yeah, that's still working. Just we don't explicitly do the swap, it's implicitly gets done with the max and min. And did this pass? Yep. Okay, cool. I forgot to mention the time complexity for this and the previous solution too. It was O of n because we just traversed the numbers one time. We can't do better because we have to check all the numbers to be able to tell the max product, right? The space complexity also is for this solution and the previous one. In both cases, we used only constant space. So in both cases, it's O of 1. And yeah, so that's pretty much it for this method. A slightly different way that we can approach this is to do something like this. So basically, we can claim something here, which is that if there is no 0 in the array, then the max product is must either start with the leftmost or the rightmost element. Basically the first or the last element. Which means that this basically means that the max product is either the prefix or the suffix of the array. So it's either the product of some a prefix or a suffix of the array. So how can we prove this claim here that we just stated? So basically, let's say the array A from I to J, we don't know that, but just the definition of the problem is that this is the max product, right? Is the max product. And to prove our claim by contradiction, let's assume that I is different than 0 and j is different than n. Because what we are saying here is if it's a max product, it has to be either have I equal to 0 or j equal to n, because that's what the leftmost and the rightmost element are. And so if we are able to prove by contradiction that this is not possible, then we can just prove our claim, right? Using it just to prove by contradiction, right? Okay, so now what this would mean is that let's call this P, right? Is the max product P, right? So if A of I is bigger than 0, we said also that if there is no 0, right? So we know that if A of j are bigger than 0, so that means that, so if this one is bigger than 0 or this one, so we are just going to handle multiple cases, right? By cases, right? So if AI, or one of them is bigger than 0, that means to get the max product, we should include it, right? We should extend to it. And if both are negative, so that's the only cases possible, right? Either one of them is positive and the other one is negative, whichever one it is, or both are positive or both are negative. That's the only cases that we have. And so we should extend it to AI or to AJ. So we know now that in this case, we should go all the way until the first, until AI or until AJ, right? Now, if both are negative, that means we should include both. We should extend to both. To whichever one, here, whichever one is positive. And here we should extend it to both because, let's say AI was -2 and then we had a certain number and we had -4. It makes sense to extend to both because if we do that, we will get -2 multiplied by -4, which is 8, which only makes the product bigger, right? And so now we know this claim. And so also by induction, we could just say, okay, that's valid if we had only 2 elements, right? Let's say I is at some position here and j is at the next position, and we have 2 elements here. And so this claim says that if one of them is, if this one is negative, we should use this one. If this one is positive, we should use, if this one is negative, we should take only this one. If both are negative, we should take both of them, right? And so by induction, we could just extend the same logic to this portion and keep extending the logic to the entire array, right? This is also, of course, assuming there is no 0, right? And so that means that we could just, that means we've proven our claim, so we can use that in our solution. And we need to also, since our claims handles only the case where there is no 0, that means we should handle 0 case, right? So that's pretty much what we are going to base our algorithm on. And so in order to, since we know that now we proved this by contradiction, we proved that it has to extend all the way until 0 or all the way until n because of this induction. So I has to go to either 0 and j. So either I has to go to 0 or j to n. So that means contradiction here to this, and so now we've proven that if there is no 0, the max product must include the first element or the last element or both, right? And so to do this, and plus we need to handle the 0 case. So to do this, we just compute all prefixes, compute all prefix products, plus all suffix products, and take the max, pretty much. That's what this means, because it's either a prefix or a suffix or the entire thing, right? And so the entire thing is also considered a prefix and considered a suffix. So let's just compute this and take the max. So how do we compute the prefix? Well, prefix is just do product as we go, and if encountering 0 to handle the 0 case, just reset to 1, right? So that we can start a new prefix. Same thing for the suffix, do product as we traverse the array from left to right. The suffix is almost the same thing, except the only thing that changes is that we do the product from right to left, which is the same as saying this is equivalent to do product as we traverse from left to right, but on the reverse array. From left to right on the reverse array, because if you reverse it and you traverse it from left to right, that would be the same way as traversing from right to left. Do product from left to right on the reverse array. So this is pretty much it, right? And the same thing reset to 1 when we're encountering 0. And then we take the max at the end. And so now that we have our algorithm, let's just compute it. So we need the reverse array so that we can compute the suffix for it. And so let's call it B. Let's just call this one A. And now that is the reverse of the array, which with Python we can just use this. And now we are going to go through the length of the array and traverse left for the prefix, which is A, and right for the suffix. So I is going to hold our prefixes, and B is going to hold our suffixes. And so we go through the length, and for AI, it's going to be just the prefix product. So the same as the sum product, we keep adding every element we encounter. Here we keep multiplying, right? And for the 0 case, so this is if AI is different than 0. If it is equal to 0, then we need to reset. So it's 1, right? That's what we do here. For the suffix part, same thing, it's I, because it's reversed, it will go from right to left. And we need to multiply by bi minus 1. But if bi is different than 0, which, if it's equal to 0, we need to reset to 1, right? So basically this means that we take the number and we multiply it with the product of all the previous elements, which is in AI minus 1 by now. And the same thing for BI, we take the product that will start from the last element because we reverse it and we multiply it with whatever was before it, right? So that would mean pretty much that if we had an array like this, let's take maybe this one. So our B would be, this is just at the initialization step, would be 4 minus 2, 3, 2, right? Now, if we do the product, if we start doing the suffix, we would have 2. And then now at I, 3 will multiply it by whatever the product of what's before, which at this point it's 2. So that would be 6. And then we get to minus 2, we will multiply it by what was before, which is at this point minus 2 multiplied by 6, which is minus 12. And then 4 we multiplied by the product of what's before, which is minus 12. So 4 multiplied by minus 12, minus 48. And that's the prefix one. For the suffix, it would be similar thing. So 4 multiplied minus 8, we multiply 8 by 3, 8 by 3, minus 24, and then 24 minus 48, so minus 48, right? And so now that we have both the prefix products and the suffix products, to get the largest sum, we just take the max of all of them, right? This one and this one, which pretty much would be the max of, because this represents all the prefixes or the suffixes, right? And so the max of all of this is just 6, right? And that's the solution, right? And so here we just return the max of A and B. If we had 0, you notice we will just have skipped it and reset the product, right? And that's pretty much it. So let's run this. So we have a slight problem. It seems like we have numbers that are seems like the negative stuff. Yep, so the problem here is that I go from 0, which means that this here would go and take the last element, which is not what it should do, because a minus 1 in Python is the last element. So I want to limit this to 1, because the first element anyway, the product is just the element itself, and that's already in the array, so we don't need to compute it. And so that's what we are doing here. Okay, let's see. It seems to work. Okay, so let's submit it. We have a slight problem with this use case. Let's put it first. So the problem is my solution says 0 and the max is 1 for this use case. Yeah, it should say 1, that's the max. So why isn't it saying... Yep, so here it's if AI minus 1, right? Because if the previous element was 0, the previous product was 0, we want to reset the new product, right? But what I was doing is that if this is 0, so I make this one become 0, which is not the right thing to do, right? Okay, so now it passes. There is a slight thing that will make this easier to read. In Python, we can just say if it's 0, then say 1 instead. So, or 1. So this means if this is 0, just make it use 1 instead. That makes it a lot shorter. This is really slow. But while this is running, let's just talk about the time complexity here. So the time complexity for this solution is the same as the other ones. We are just traversing the array once, and so it's O of n. And the space complexity is just O of 1 because, no, sorry, it's O of n because we are using an extra array here. So it's slightly worse in terms of space complexity than the solution we had before. Okay, so it does look all right. Okay, so let's submit. Okay, so that passes. Yeah, so these are the different methods that we can think about solving this problem with. And yeah, that's it for now. Thanks for watching. See you next time.